Good morning, everyone. I'm glad to be here. Can you hear me okay?
Yes.
Last time this thing was almost in my nose, so every time I breathe was just... This time is better. So yeah, I'm going to talk about chaos engineering with a service mesh. Does anyone here know what those words mean? Okay, good. I'm in the right place. Who here understand what is a container? Oh, most of you. Good. Okay. Do you know what is Kubernetes? Most of you. Okay. No worries. I'm going to explain what's its use and. Do you know about chaos engineering? All right. Yeah, very good. That's what it started. I'm going to explain like how it's related to service mesh, although it's not, but it's more about how your organization can recover from failure. So hi, my name is Julien. I think I call myself a site reliability engineer because that's the best term that applies. It's what happened when a software engineer is tasked with what used to be called operation. So I was a software engineer, and now I do mainly operation and automating everything in the cloud. I used to work at places where they do things at global scale. So I learned a lot about everything related to scaling a team to scaling services. And actually your organization is to adapt when you do things, when you have people all over the world and you have to synchronize and everything. If you want to contact me, this is the place. Feel free. On Twitter, my DM are open. So what we're going to talk about. First, I'm going to introduce what is the topic. Then I'm going to explain to you the architecture behind a service mesh, because it's a term that is very hype these days, and I'm going to try to break it down for you so you can maybe look into it. I will demo it with two open source projects called, one is Envoy, the other one is Istio. You might have heard of them. Then I'm going to explain to you what is chaos engineering and how we can use it in the organization. And then I will demo a live case of doing chaos engineering. And I put Q&A in the end, but feel free to raise your hand, interrupt me. I think now we have the time, so I can, have a conversation rather than just, here it is, now what do you think? Okay, so in most organizations, at the beginning there is an app. If you're a startup, you start with a single app, and it's usually all in one place. You have that app, but then you get some customer, and that code needs to grow and evolve. And so the more customer you get, the more you need to, what should I do? Now we have too much, you have what you call the monolith. And people recommend you to break it down into microservices. So far, do you know what is a microservices? Good. So with the microservices, you reach new problems, like how to deploy all those services. Before, if you have one app, you have one way to deploy, which everybody know and can teach each other. But since now everything is split up, you need to find, okay, this app might be in another language, or it's a little bit different, or you need that database for that service. So for that, the containers came and standardized and give you a way to actually describe, okay, this is my container, this is how it should be built, and you can ship it. So it's very much separate the concern of how you build the app as opposed to how do you run the app or operate the app. You have the thing that changes is that you have to code your application regarding some 12-factor app. Have you heard of the 12-factor app? It's a manifesto that is being since the beginning of the container, that it's a set of guidelines that tell you, okay, don't write the logs to a file, write them on the standard output, because in the container the file system is not the same as when you have a machine. So it's a lot of tools and guidelines to make your application easier to manage inside a container. It gives you reproducible build, because how many times you say, it works on my machine, right? Okay, well, been there. But that's not the only problem you get. Then, now you have container, you have microservices. How do you do all that? Scaling up and down. redundancy, but maybe you have 2 times the same service or 3 times. How do you schedule them? Because they are on different machines. How do you know how many services run at any time? You know, how do they find each other? Because usually your services are just not a single entity. They need to communicate, exchange data. How do you make them resilient? And all those questions, they come, and finally, the answer came and Kubernetes arrived. So Kubernetes is tool that you install on top of your infrastructure. So if you have VM or server, you install Kubernetes and you write a manifest telling Kubernetes how it should run your containers. How many containers do you need and what you should do with them. And you can fine-tune those manifests in order for Kubernetes to provide you the service level that you expect. But you still have the network. So there is this 8 fallacies of distributed computing, and that's the first one is my favorite, is the network is reliable. That's the biggest lie ever. If you ever work with code and you try to send a package and you say, okay, did I receive it? What's happening basically? Things can fail and can fail in a way that you don't expect to. And the thing is that it's not a new problem. Like 22 years ago, someone wrote an RFC, and that is still relevant. It's 3-page long, and it's kind of like a joke, but it's funny because it's true. That's what I mean. And so, but once you have Kubernetes, you still have all of those to figure out. How do you do logging? Does anybody here have the app that when it fails, it just spots like terabyte and just fill the disk and then you have an outage? Like we're in 2018 and this is still happening. Like disks are still getting full by logs. Tracing. How do you know? Because now you're talking with many requests, many services. How do you know the path of a request? How do you know if there is a bottleneck somewhere? Someone come and say it's slow. Okay, how do you investigate that? All those metrics that you need to gather, like is the service healthy? How do you know if it's working correctly? And how do you know which service depends on which services? Because now people are in different teams, probably in different time zone, and you have to work with that. How do you make sure that, you know, people, the services have the right credentials? Because admin all is a little bit dangerous, if you know what I mean, especially if it's written in clear text on the disk. So if somebody gains access to that, you're going to have a bad day. Circuit breaking. That's one where it's kind of like, okay, I don't know what is wrong with this service, but if I keep serving requests to it, it will keep on failing. So I just cut it out. That's something that is kind of hard. If you ever had to implement that, you might get it more or less right, and then you might break everything trying to do that. And then you have like traffic flow and policies. Who here has ever tried to do a canary release? Do you know what is a canary release? Okay, well, maybe I explain. Yes. A canary release is, let's say you have a new version of your product, and you don't want to roll it out to all your users. You just want a small part of your user to use it to see how it reacts. Then you do a canary. It comes from the coal mine. You know, they blow the canary in the mine, and if the canary doesn't sing, it means it's dead. So there is some gas, and you need to go out. It's the same idea. So that routing just a part of the traffic is really hard. You have to have deep knowledge of the system, and most people have just the knowledge of the team and the few of their services, but barely people have a really wide knowledge over it. Failovers, you know, what happened when you can talk to the database? What should we do? Should you just like, you know, the web page should just return a 404 and you have something weird and you don't know what happened? Will your user come back? I mean, when I talk about those errors, this is usually impacting your business. And fault injection. You want to test sometimes when things go wrong so that you know how the system reacts. Not really because some people, they just break the system knowing how it's going to react. It's not going to work that way. But sometimes you just want to test something really special, like what if in that case a customer clicked there and then has this configuration. So that's a really more advanced way to test things. And for all of those steps, we use code. Because developers love to code, that's what they do, so they put more code, and with more code come more code. Yes?
When you were talking about fault injection,
yes.
are you also talking about injecting faults into production?
Yes.
Okay.
It's mainly in production. You can test it locally, but that won't give you the... I mean, if it works on your laptop, I mean, what can we do? You know, and then... You know, we have a saying like, oh, it works on my laptop. Well, back up your email because your laptop is going to prod now. Yeah. So that's a little bit the joke we make. Like, who cares? Who cares? And you want to test the real thing, and that's why service mesh is coming to be really handy. Because all those points are super hard to get. Doesn't mean you cannot do it. It means it's hard to get right. And so on top of that, I'm pretty sure that none of you use the same language with the same framework with the same version. So you usually have some Java and Groovy and some C# and some of those different framework and different version of those framework or clients that you need to use. And so testing things comes pretty tricky. And some of the developers they say, no, I'm not going to upgrade that library because otherwise it breaks half the test. So it takes time to migrate. Code gets rotten really, really fast. And to get it right, to get it really isolated, it's kind of something that comes out of the experience. You need to fix the same problem over and over to understand, okay, now finally I understand how to do it. You know what they say, to write it right, write it twice. But I don't know how your product manager is going to, like it, and you say, well, it's going to take twice the time because we have to redo it now. So, yeah, and all those things like maintenance, upgrade, who here run the latest version of the code base, like client libraries and everything? Well, because it's hard, right? You don't want to come up in the morning and say, wow, I really want to update that library today. That's not what gets you out of bed. What gets you out of bed is I want to fix that problem. I want to implement that feature. I want to make my user happier. That's what helps you. Also, it's super hard to retire a service. Many people say, oh, we're going to break a monolith. No, you don't. You're going to live with it for another 10 years. Because so much engineering power has been involved into that monolith, you cannot just break it down into microservices. Or you're a seller. You can sell. And you're selling microservices products. But I don't. I'm a developer, so I've been through that. Also, I don't know if you know, but testing those, if your code is calling another service and you have to test that code, what do? Do you mock it? Yeah. Do you implement something? And then your tests are, they pass, but are you really sure that that's how it behaves? So there's tons of unknown here. The deployment, I saw many really weird deployment. Even if you have Kubernetes, you still have the part where, okay, what happened when you run a database migration? So you just want to add a field into that. But your code is built for the previous version of the model in the database. So which version do you run? How can you stock everything and suddenly you're in a train and you cannot stop. So you have to always ride two horses at the same time, and that is another management that you need to do. Yeah, and I mean, how many people have really said, oh, that time for that service we're going to use a different language because that language is more suited to the need of that service. Does anybody ever heard that? Exactly, because you know one language, you're going to use that language for the other. So why bother? Because there's too many new things to relearn every time. And so yeah, debugging is a big one. Are you really sure that it works on my machine and then suddenly in production it doesn't behave like that? Or we didn't change anything and suddenly it breaks, so it's not your fault? Right. So the idea is all those points, make that code to another service, move it into something that is in the infrastructure. And that's where Envoy came. Envoy can really abstract away the network for your application. And that's what it does. It's an open source project. It's written in C++. It's very async, so it never blocks, and it's just really performant. Let's do a little demo to show. I want to show you what it is so that you understand. So here, I have HTTP bin. Do you know what's HTTP bin? Maybe I can show. That's HTTP bin. You have those. Maybe I can find the headers here. Yeah, basically you query some endpoint and it gives you back whatever you queried, so you can inspect. It's a really good debugging tool. And so that's what I have in the upper one here. In this, I'm going to query that, and you see it's going to print the headers that I sent in my response. So here, that's the header from my request. It's running into a container. That's what the query is weird, but that's basically the URL I'm querying. Now I'm going to run envoy in front of that HTTP bin. So that's envoy running, and if I create the proxy, it's still the same. But if, I'm going to query the proxy here, and you see now envoy has added some headers. So by going through envoy learn about your request. He knows where you're going to send it. He's going to route the request and rewrite some of the things. So you have one abstraction between you and your service you're trying to call. And that leads to a very powerful pattern that's called sidecar. So for every service, you attach one envoy, and the service now doesn't communicate directly with other services. It goes through envoy, and envoy communicate with other envoy. It's going to make sense in a moment. Don't worry if you don't catch it right away. So far so good. You understand a little bit more about envoy, just rewriting the headers. So let's talk a bit about the sidecar pattern. So you have your microservices, and they talk to each other. But the sidecar pattern say, okay, if service A needs to talk to service B, it should not go through directly talking to the service B. It should go through the proxy. The proxy is the envoy. So that's why it's called sidecar proxy. It lives nearby the service. What gives you is that now every request goes through the proxy. So you know exactly how much your service is talking, to who is talking, and you have actually a hook where you can define rules about what this proxy should be doing and how it can be, and even facilitate. Because now you don't need to know about service discovery. The proxy can know. You can just, okay, I want to talk to proxy, I want to talk to that service. Yes? 2 questions.
Would you consider the proxy being a part of the client side or the server side of a service?
Both.
Both. Okay. Next question. Back in the day when the big dinosaurs walked the earth, we used to call this a service bus.
Oh yeah.
So maybe you will elaborate on the difference.
The service bus is more something that is, you think, is it like CORBA or some remote procedure call or?
Yes, or WebLogic.
WebLogic, yeah, I haven't used those much. I wouldn't venture into explaining what is the difference between a service mesh and this bus. All I can say is that this is very low level. It's completely transparent to the application. That's the only difference I can see. Service B doesn't know about the proxy. It doesn't know about where is service A. It's like you have a phone, and instead of having the phone number, you have to query a service that tell you the latest phone number of your friend. Otherwise, you have to call your friend and say, what is your latest phone number? But you want to talk to him, so you can, it's like. So the main thing is, it's transparent.
I would also say that the enterprise service bus is a monolith. It's one big application that sits in the middle. These are services. These are microservices that are coupled to other services. So that's one
good point.
Thank you. Exactly. Does that answer your question? Very good. What was I saying? Yeah. So the problem comes now when you have so many of those proxies. How do you configure them? You know, like you have to tell, okay, this is where service B is, this is where service A. Make them talk to each other. You have to configure all those proxies, and that is a service mesh. So you have those proxy, and you have the service mesh, which is like the connected proxy. And in the service mesh, you have services that configure those proxy. So do you understand more what is a service mesh? All right. So now this is clear. If you want to understand like where does that come from, is you have this video made by Google product manager, and basically they went to all the big clients and saying like, okay, what are the problems? And they fit it into 4 categories. So people want, services want to connect, they want to talk to each other, and they don't want to reinvent the wheel on how to discover what is the IP. You know, it's like this, they want a proxy service. I say, I want to talk to Thomas, and then the service is going to route me to Thomas, and I don't need to care where Thomas is or which device he's using. Security, since now you have the proxy in between, nothing prevents you to encrypt that traffic between proxy. Because the proxy lives nearby the services, it stays on the same box or same pods in Kubernetes. So all the traffic that's coming from the service, that part is not encrypted, but the part between the services, the proxy, is encrypted. So if you heard about this thing called GDPR, it just requires you of encrypting your communication. That does it for you with just a little bit of config. So that's a big advantage if you have that. Control. Since now you know exactly how much traffic is going through your service, nothing prevents you to say, okay, 10% of that routed to that service. Or even better, copy the request to that part, to that cluster. So you can do actually very silent and reproduce those steps. I mean, the problem is very hard when you have to say, okay, is that a copied request or is it an original request that I really need to take care of? So those things help you a lot to fine-tune and help the service. And observe, since now you know everything that's going through, you can inspect what is in the request, saying, okay, how many 500 requests do we have? You know, at any given time, this is real time. You can know and see who is calling who. So maybe some services should not call certain database, if you know what I mean. And you know, you can enforce policy about all how the services are talking. So when yes,
would it be accurate to call it service mesh for a control plane?
There is 2 parts. There is the control plane,
yeah,
and there is the data plane. The data plane is the proxy talking. The control plane is the service that configure those data plane. Does that answer your question?
Yeah.
So when I have to explain what is a service mesh, I like to talk about what problem does it solve. And the main problem it solves is communication between services. Because now you just have one monolith. You have many little services and they all talk to each other. And so in that, remember the 8 fallacies of distributed computing. The network is not reliable. And so you have to handle those cases, which it's a new set of problems basically. And so if you want to make it short, you can say like a network for service, not for bytes. That's a service mesh. But how does it solve that? Well, this is because of the control plane. And you see the proxy, the envoy proxy, is controlled by those by this control plane. You have the pilot, which tells the proxy where to find which service, how much traffic should go. It shapes the traffic given any proxy, and that's where that lower part is the control plane. All the proxy leads to define what we call the mesh or the data plane. And you can see that for every request now, we send another request to the mixer. This is Istio naming convention. I think if you take another service mesh, you will find another name. But basically, they want to gather how much data is going through each proxy. And you have Citadel, which is very interesting because if you ever had to rotate certificate time to time to allow encryption, you know that it's quite painful. So this service does that for you. You can just, by flipping a switch, okay, now I can rotate certificate automatically. I don't need to care about it that much. Yeah, I want to be careful because I don't want to sell something that is not...
You're a developer, not a seller.
Yeah, exactly. Exactly, that's true. But so now I hope that you have a better picture of where does the service mesh fit into your microservices architecture. It's a way to abstract the network. It lets you define how servers talk to each other and help you have some visibility, because now all the requests, you see who is talking to who. And that is very powerful if you ever had to observe and debug something. So a little bit more technical, but I won't lay too much into it. So you know the OSI stack, 7 layers, and you have the service mesh. So now you have containers, into which the application runs. Then you have the mesh, which is a filter, so it's above TCP. And then you have the tags, which is where you can define routing. So for instance, you can tell the proxy if the service call a route, or if the service has that, if the request has that headers, just route it here instead of there. So you have a more fine grain towards your application instead of having to use IP tables, or dealing with IPs in the cloud is super hard because they change all the time. Service come up and down, the IP just get reallocated, and it's a management that you don't need to deal with. And so that's mainly the control plane. It abstracts away the management of the proxy. So Envoy is very well abstract. Like you don't see Envoy. That's what I mean. You just have your YAML to define what it does and what you should do. And of course, this is usually used in the cloud. So you might have to communicate to some service in the cloud. For instance, you will have to tell how traffic can reach your cluster and how it can go out, because by default there is no route. You're going to the Envoy. So you have to tell, okay, this service can talk to that third party, or this is where the entry point of my cluster is, because by default everything is locked down. Now it's very secure. It's I would say you start from scratch, but you can very fine-grainedly define exactly everything you need. And by looking into that, I always wonder, what's in the code? How do you have to code your application to use that? And that's very simple. You just don't care much. And the thing is, okay, it's the same if I want to talk to someone. I just need to know your name. I don't need to know your phone number. And that's the same. If this service, I took that from the demo that I'm going to show. If I want to call the service details, I just talk to the service detail. I don't need to know the IP of the service detail to talk to him. And so the reason there is a port, which doesn't have to be, but by default, if you don't put a port, it's considered AT because it's HTTP. So there, but here we add one so that you can have a specific port talking. And so all that makes it super easier. You don't have to know how many doing client-side load balancing. Otherwise you have to query, okay, how many instances? What happens if one is down? And then suddenly in the code you have to manage all that. Here, all that management is taken out and put in the proxy. So traffic management, how do you define? Okay, I want that user. So if there is a header in the request containing the user JSON, just route it to that version of the service. If not, just send it to the normal version. So I can have a canary release, route some user to a specific new version, and all that within a few lines of YAML. So that's a little bit like compared to how much code you had to put before, you have to put a configuration now. That configuration can live nearby your code so that you can define in your code, in a version environment, what is the network supposed to be. So now you have a version of the network. So it's code, infrastructure as code is part of that. You want to have code for how to represent your infrastructure and how the application is supposed to interact with it. Resiliency. Does anybody here has ever had to implement a retry logic? So if it is who DDoS himself? Yeah, well, you haven't lived if you haven't tried, right? But basically here you can just specify, okay, retry 3 times. This is the timeout. After that, just return the 500. And so I don't know, but I tried a few times, and it's really hard to get right. What you do in your code is you basically forget a bunch of use case, and you say, okay, I'm going to do simple, and that simple end up being a mess. So here you have a very strong way, very battle-tested way to do it. About security, now you can enforce policy like, okay, only that service can talk to that database. No cross-sharing database and people run, I depend on that same table as this service, but they both write at the same time, and now everything is a mess. So you can enforce those policy in the infrastructure, and nobody can change that. So you can reward good behavior and prevent bad behavior. Bad behavior in the sense that, okay, somebody is stressed and you have to ship something, and people take shortcut all the time. Mutual encryption. So that's a kind of nice feature, so that even if someone gains access to your physical box, they still might not see what is going through. And role-based access, that is something related to Kubernetes. Yeah, observability. I mean, all the things, now you have traffic for free. You have metrics for free, sorry. And the logs and all the... You can have also observability, because now this is my the schema of my services. I know what it looks like. I know who talked to who, because those routes have been defined somewhere. I'm going to show you in a minute. Oh, yeah, it's time for a demo. So as you see here, we're going to send traffic to the ingress. There is a Python app with a proxy, with Envoy proxy, and this Python app is going to talk to a review service and a detail service. That review has 3 versions. It's not the best practice, so don't do that, but it's just to show you that there is different stars that are coming. If I show you, this is the application, and so you see no stars. Now you have the review that has stars, no stars, and then red stars. So for each is a different version. And maybe I can, yeah, now the traffic is in place. I can maybe show some traffic. It's going to take a while, and then you can see real time how much the percentage of the requests are going through. 15 seconds, come on. Maybe I should, do I need to, sorry. Yay! Yeah, right? But so now you see that the requests are equally load balanced. So by default you have the round robin, which is like just go one after the other. But you might want to have some finer grained control over that. Let's lock everybody to version 1 here. So the traffic is just going to call version 1. It doesn't contain any stars in the UI. So let's do that. Okay, so what I did here is I applied a manifest to Kubernetes. So the way you install Istio, maybe I should have spent some time explaining that. The way you install Istio is that Kubernetes is extensible with what they call custom resource definition. So you can interact with Kubernetes in a way that is specific to your application. They do that notably for database, because database requires some different deployment sequence than application, for instance. And you have to handle storage, so there is some state that you have to manage. And Kubernetes is very well suited for that. So they provide you an API, and Istio come and hook that API and manage to allow you to define route. So that's how you get those things. And now if I try my application, if it works, I hope. Why is it so slow? Okay, so now you see, doesn't matter how many times, I always get the same service back. If I look, yeah, the two other services are not called. And that is great, because now I have a very, all the data that's coming through, I can see, I have a really nice dashboard, like showing how much resource, what's the workload, how many requests fail, how many passed, what is expected. And you can define very clear service level agreement. You have all the logging in the world, and the best part is you can do tracing. So tracing is what happens when you call the service. You see the time spent on each request, because now everything goes through the proxy, so you know exactly when it comes in, when it comes out. And you can see here that if you want to optimize this service, you can just call two requests in parallel if the data doesn't depend on the previous one. So you can make those decisions by actually seeing what's happening. And that's the difference. You don't have to read code and load your mind with the problem and trying to figure out. This is something you can see and can reason about. So, but what I want to do here is to show that you can allow your user to use a specific version. So I'm going to apply the manifest that says that it's the one that I showed, that you saw earlier. This one. So I'm going to force the JSON to use the version 2 of the service. So here's my app. It's still version 1, and here is JSON user. And you can see here I have the star. So in the background it's talking to two different services. Oh, right there. And you can see the amount of requests and the latency and everything. So that gives you a very powerful tool to visualize whatever happened in your cluster. Okay. Any questions so far about service mesh? All right. Yes.
Who owns the service mesh?
Usually it's the operation side, because they are in charge of making sure that those services that control the envoy is up and running, and that all the metrics get received, and that basically what is defined in the manifest is actually applied in the network, in the cluster.
And the developers who develop the microservices owns the respective configuration of their sidecar, or?
You can do like that, or it really depends how your team is comfortable about defining, YAML. And because some people, they just like, no, I'm not going to touch that. So what do you do?
Because I see that's the only difference between already existing middleware, which we've been working with for 20 years, because we have all these capability which you showed, but not as nicely packaged as this product. But I think the ownership and the team responsible for actually making it happen, that's where you can...
Yeah. It's more organizational change. I mean, you can make it work with code, and people have been, if it's work, don't fix something that's not broken. That's my first advice. But the thing is, this is when you have multiple teams in different places, and usually one make a change into the infrastructure and they're not documenting it, or they don't have infrastructure as code, so nobody knows what the hell happened. What is the state of the infrastructure? I mean, infrastructure drift is a really big bottleneck for developers, because I've been stranded like 2 months for something I could not deploy because of some project was migrating and I could not, this is impacting the way. It's a self-service type of approach, is that you can do it, but the main purpose is that you can move fast and just redefine your new services as much as you want.
I really see the benefit.
Yeah, it is very much, but once again, the cost of maintaining and operating this is not, you don't get that for free. You might need a team to, manage and handle that. So it depends on the skill, but this can bring you to like okay skill to hyper skill. Like, that's what this come out of Google and IBM because they needed it. So they make a joint venture on how, to manage that. Yes?
So I think Björn is absolutely right. This is middleware, and hopefully this is middleware made right this time. But the question I have, getting back to the fallacies, how much overhead do you add to your network? How much bandwidth do you need to have this kind of monitoring?
So
I see the value of it.
Yeah,
that's a cost.
Definitely. And I think it's a very valid question. The cost is for every request you make to your service, you have one extra request that's going to the mixer because you need the metrics.
Yeah.
So that's the traffic. Now they mitigate that by explaining what is the real cost. Like what do you gain out of it? Yeah. Is it worth it? Basically, but most of the time the answer is yes, because it's using Prometheus behind the scenes, so you don't get the pooling of metrics is something that is it's a pooling strategy instead of pushing strategy. So you have all those different patterns that you can set in place. Second thing is this is like kind of a la carte. You don't need to buy into the whole thing. Okay, now in that's in theory. In practice, to untangle those things might take you a little time because you need to know the product very well. You need that's why I put other service meshes, because this one is the easiest to start with. You can up in your laptop, you can feel how it is. You don't have to fiddle too much. But now, on the other hand, if you just have one monolith, you can use Envoy. Because Envoy, that's what it does. They started at Lyft, so the ride-sharing company, they implemented that because they had this big monolith in PHP, and they wanted something to handle the request. This Envoy can handle 2 million requests per second. The time it takes is constant. So the reason it is because if you have a proxy in front of something and you have a bottleneck somewhere, you want to know how much time this takes. And this needs to be constant, otherwise you're going to wonder, is this the proxy that's messing up or is it my service? So no, the goal of Envoy is to, where you can deduce where the problem is just by hearing about the problem. It's transparent, and that's really the idea here, is that I think it's less than 1 millisecond it adds to process a request. So I would say the latency is not really a problem. The performance is not a problem. That's what I mean. It's really battle tested for years, and they are really advanced in it. The thing that changed is really how your team interact with it, how your code interact with it, and how to migrate from what you have to something that you can manage like that. That's the challenge, basically. Does that answer your question? Okay. Yes?
Two questions. The first one, I saw that you mentioned Mesos, and also, what was it? It was another different container layers, so to speak, not just Kubernetes. So I was wondering, Mesos and Kubernetes...
There are many orchestrator, you mean?
Yeah, I'm talking about the layer below that's running the containers. Like Mesos, you can use that in place of Kubernetes, right?
Yeah, that's a scheduler.
Yeah. So I was wondering if there's, if you have overlapping functionality already built into these scheduler services and service mesh. So, like service mesh, is it somehow bringing a convention which replaces parts of Kubernetes?
They work more hand in hand. And by that I mean that the purpose of Kubernetes is to fix your deployment. Yeah. You have Kubernetes, your deployment, it's a YAML manifest and you're done, mainly. But with Envoy, is how those services talk to each other. Because now suddenly you have a new version of that service. How do you manage the communication with that new service? You understand? By default, Kubernetes roll that, it's called rolling update. So it just let the traffic, it doesn't kill the previous version before the new version is up and running and receiving traffic, basically. That you can configure that, but the main idea is you can take control of that. Because right now you don't. If you define a new version in Kubernetes, you push the manifest, and all the traffic is going to automatically being 100% rolled out. But if you want to roll something gradually, that's where the service mesh comes in handy.
Service mesh really, it's only about orchestration, and it's not. Most of the things are not done by Kubernetes.
No, but they interact with Kubernetes. So in Istio, communicate with Kubernetes to tell where everything should go. Does that make sense?
Yeah, sure.
It's, you know what they say, everything can be solved with a layer of abstraction, except too many layers of abstraction. And that's what it's super hard, like, it's not obvious. If you have a problem, if you have to debug something inside the service mesh, it's not going to be easy. You're going to need debug tool, you're going to need to know about the network. It's not like, okay, I wrote my manifest, it works. No, and that's what I mean. You need a team to manage that operation. So, I mean, it's mainly built, the Istio is built for Kubernetes. But you can use console. You don't need Kubernetes for that. You can use Linkerd, which is like, you don't need Kubernetes for that one. The reason I use Istio is because that's the one I know best, and it's super easy for me to spin up a Kubernetes cluster these days. So I can get a demo running in 10 minutes. But I highly recommend you look into that article, which compare console and Istio, and it helps you to basically make decision about what you need, because Kubernetes.
And Istio, are they for service discovery? I don't.
Istio is the name of the project that is implement a service mesh.
Yes.
So all those projects are service mesh.
Okay.
Envoy is the proxy that is built for the
application.
Yeah.
I was going to ask another question, which is about. I recall reading a lot about. A few years ago, I read a lot about Kubernetes and how you're supposed to set up like a data center, and how you're supposed to orchestrate all the services and everything. And I didn't really find a lot of these complete solutions for orchestration. I'm wondering if you know if there's, is this, how recent is this project, and are there a lot of similar ones to it?
Similar to Istio?
Service mesh.
Yeah. Well, that's the list of all the service mesh I know.
Okay.
They are 1 or 2 years old.
Okay. Right.
Kubernetes is for 2014, so 4 years, and they are meant for different things. So Kubernetes is very much to orchestrate your container. And
but I think I understand. Never mind.
Okay. Another question? Okay. So we can go to the second part of the talk, which is chaos engineering. So what is chaos engineering? And so you come up in the literature with some official definition, which is chaos engineering is the discipline of experimenting on a distributed system in order to build confidence in the system's capability to withstand turbulent conditions in production. It's a mouthful. Basically, it means like if something breaks in production, your system doesn't completely fail. So you can withstand some troubles. And see it chaos engineering as a vaccine. You inject something harmful into your system in order for the system to react to it and to help defend himself. But it's nothing chaotic about doing chaos engineering. That's the term. It's more about you have to plan your experiment, and if you break the database in production, you know exactly what's going to happen and you're not going to like it, so that's not chaos engineering very much, but you get the idea. So chaos engineering isn't done to cause problems, it's done to reveal them. So what you want with the chaos engineering is to know how your system reacts and how you can detect problems that nobody has thought of when they build the code, because different teams, different product, different version. So that's not chaos engineering. And the reason I put that is because you have this saying that hope is not a strategy. in your product, it's not going to help you much. And so it comes on to many different things, but usually people don't test those hard things. Like, everything needs a health check to know if the service is still up. How do you test that? How do you know if... I see a health check that even if the service was misbehaving, it was returning a 200. So nobody could find out what it is, except that, it's not connected to the database. But the service is up. It's not going to help. All those things about timeout. Probably every one of you're using a library. There's a default timeout in there. I'm pretty sure you don't know what it is and you don't know how to set it. And that's going to bite you at some point. I hope not. But, yeah, some of us have been there. And so the deployment as well is, sometimes you want to test, did the deployment run nicely? Is it really up and running? Or is it just like, okay, the process started, but the connection, hasn't, or the connection to the database happened before some other thing, and so things crash? It's kind of hard to know. And what about Graceful Shutdown? When you roll a new service, do you really drain the request? Or there's a few requests that get, discarded, and your users see some 500 and they don't know what it is. And then you look at your metrics, everything is fine, the new version is working. So it's a very much the connection between what your users see and what happened into your cluster. And that level of detail has tons of impact, because people can go over things going bad if they know what happened. But if they see just a 404 when they used to see their data, you're going to complain. If you go to your bank and you see that the numbers are wrong, you're going to complain more than if, the service is not there, or if they tell you we are running a maintenance. That's more important. And so testing for different type of errors. What if testing for a service that is unreachable is not the same for if the service answer late. Like slow is super hard to detect. But timeout as well. Defining, okay, how many times should I try that service before, stop serving traffic to it? It doesn't bring anything, it just brings things down. And also, I'm pretty sure you know that writing code, you have to sometimes change the schema of the database. The amount of code going into that is insane, because you have to handle the two schema at the same time, making sure that depending on which requests come, you know which database to call, and all of that work bring nothing of value. That's time you could have spent working on features, making the product better. Instead, you have the same product, just a different database. Your user don't see that value. And so Google came up with a book called Site Reliability Engineering, and it's a really good book. And inside that book there is a chapter on SLI, SLO, SLA. Does anybody know what it is?
Service license something.
Yes, sir. Let's see. I'm going to show you because they have a really nice... So SLI is service level indicator. SLO is service level objective. And then you have service level agreement. Service level agreement, you might have heard of it. That's the contract company make when they use a service. So, I don't know, Amazon has a 99.999% of uptime. That's about 15 minutes per month, I think. So they can be down that much. On top of that, you can ask for money back. So SLA is basically money to your business. From you, if you make an SLA, or if you're using somebody and relying on their SLA. And you can see that SLI is the measurement describe basic properties of metric that matter. So that's service level indicator. Is it the number of 400 requests, 500, 200? The objective is what those values we want those metrics to have. So you define your metrics, which might be something like does the service answer the response time of a service. Then you have the service level objective, which is it has to reply under 100 milliseconds. And then you have the service agreement, basically how much you're going to pay if things go wrong, or how much you're going to get if things go wrong. So this is really business impact. So now we connected how your service behave to how much money is going to come or in and out of the company. That makes people pay attention usually. And so with all that, I don't even need more traffic. So with all that, we should see some workload. You can see like here is the number of successful requests. So you can see your uptime, your SLA in real time, and you can have those monitors, to see like, okay, should we do something or not inside the company. It's allow for a lot of responsiveness. And so in chaos engineering, we do what they call a game day, and that's we're gonna try to break something down and make it fail and see what happens. I put a link into that because you have to, how to break DynamoDB. And what some people do is they try to put a lot of load on DynamoDB to see how it reacts. And so they have auto-scaling, so the database usually scale up. And what they find out is that they cannot scale down. So they are stuck with a really big build and they don't know what to do. And the only thing is to migrate database. So if they didn't do that, they wouldn't find out that it was actually a good practice to know how to migrate a database from a big instance to a smaller instance. Otherwise, you're going to be stuck with a big build that's, people are not going to be happy about. So that makes sense to business. This is linked to your organization. And so the thing is that in your organization, you can expect failure. Whether it's, the fire drill. If you're the only one doing it, you're going to be stuck outside alone, and you're going to wait for the alarm to go off while everybody shout at you because you triggered the alarm. So it's not really something that you can do alone. It's very much an organization part of it. You have to expect failure and learn from it, because if you don't learn from it, it's going to happen again and again and again. And what are those people doing? Firefighting. They're firefighting all the time, but that's not good. It's not healthy for those people, because they get addicted to the stress and they cannot chill after. And after that, they spend their time on something that they could have improved something instead of fixing the old stuff. And so the main thing to know is to practice. You practice a fire drill, I guess, every year. So if you just do it once and call it a day, you're not going to get much value out of it. It's very sad, but you have to keep practicing. And one key thing is to publish a report. Document what happened, what you do, what you try. Even if it's just one page, it's going to help you tremendously, because now you have something concrete to work on. You can share that, and people are going to come back to you with ideas. Because, and I take that from Netflix, who kind of came up with the term. Doesn't matter how much problem they find. If they go see the engineer and say, we find those problems, and you have 500 problems, they're not going to work on it. They don't know how to handle 500 problems. But if you say, okay, those 3 problems are the main one that really impact the customer journey, they're going to work on it. They're going to, make that a priority. But nobody can prioritize 500 tickets or something.
What is RCA?
Root cause analysis.
Oh.
Thank you. It's what happened after an outage. So, they have this blameless culture. So things happen, people misconfigure something, and it was undocumented, or somebody made a manual change in the infrastructure and suddenly things break. So those are kind of important into your organization, but all that is very emotionally charged. I don't know if okay, you might bring on some, it would be a good idea to bring some psychologists or something to help people process those emotions, that they say, okay, doesn't mean you made a mistake, but we need to learn from it, we need to move on. And so, I saw this picture. Have you heard of the Toyota assembly line?
Yes.
I take that picture because they have this idea of Kaizen. If you take the character separately, it means change for good, change good. And that's the idea of continuous improvement. They don't care where in the line there is a problem. If there is a problem, the employee just pull the cord, the manager come and check if the problem is serious or not, and if it is, it can stop the whole line. I don't know if you realize how many people get to not work in that time and how quickly problem gets fixed. So that's a way to let the whole company being involved. And that's the point with chaos engineering. The whole company can be involved, from product to operation. And so that's the way people don't get blamed for things. They detect problem early, so problem get fixed early. A word of caution though. If you go and see your manager, I want to break things in production. It's like if you're coming with a vaccine, you're coming with a syringe, you say it's going to be good for you. Nobody is going to trust you. Understand? You have to explain what is the vaccine, what is it going to do, how you're going to recover from it, what happens if things go wrong. So you want to tell people and communicate this idea that, okay, the result of chaos engineering is resiliency. Your system will survive trouble in production. And that's the main idea here. You want to sell that. Not chaos, we're going to break things, it's going to be fun. It's like saying, you see the people who are sprinting 100 meters, you just see the less than 10-second part. That's the breaking thing. But you don't see the years of practice they put behind before running those 10 seconds. So that's the idea here. Breaking things is a very, very small part. Chaos is inside your system. It's not something that you bring in. Chaos is inside and you reveal it. You expose it. That's the idea. That's Chaos Monkey. It just mimic a system, a common failure that can happen at any time. That's the chaos here. The chaos is in the system and you want to know what it is. So this is how to start chaos engineering. You might not want to talk about chaos and more about resiliency first, because the word makes people freak out, it's just the way it is. It's hardwired. Set up monitoring, because if it doesn't get measured, it doesn't exist. You won't be able to write a report like, I tested this and this is the result. If you say it was good, who's going to trust you? You need something measurable. It's like saying, does it scale? What do you mean, does it scale? Does it scale to 1,000, 1 million? What is the scale you're talking about? You need numbers. You need about that number type of thing. You need to give people an idea of how big it is. And then, if you have services, you can have like those monitor, and they're gonna follow some kind of pattern. After a week, you get used to them. That can be looked at as your steady state, like the average state. You might have peaks, but that is part of your steady state, because you know that at that time, at that point, that service is gonna receive a lot of traffic. If you're doing in the TV industry, some shows have really big spike and then everything smoothen out. Then you can form an hypothesis, like, would a timeout still make the whole service down, or can we still show something to the user? For instance, Netflix has some feature where if they cannot show recommendation, they just show a list of the most viewed show during that day. And that's a fallback. That's something you can improve, and the customer experience is just as good. It's not perfect, but it's much better than nothing. And so you can simulate those real world events. And I'm going to show you how to do with a service mesh. You define a timeout, basically, into a request. Then you try to disprove your hypothesis and write a report about the measurement and the findings. Like, okay, we know that service, if it doesn't respond below 5 seconds, we're going to have a timeout that's causing this into production. Then you can talk about chaos. And the main thing is to redo the experiment. Like, continuously practice and improve. And the more you do it, the better result you're going to get. So let's see. Now I'm going to show you how to inject, how to do fault injection into JSON requests. So I have my service. I'm not going to touch my user. I'm going to touch just JSON because I don't like him. So, where am I looking? So, is this? Okay, I know what it is. So these are my user. You see, they still. I'm going to show you the network tab, but they are still stuck in version 1. So this is the service is not impacted. But what if I want to show that JSON he's been mean to me, and now I have the control to really piss him off. He is still logging in V2. So what I'm doing is I'm going to apply the manifest to inject the delay into the JSON request. And so, let's see, my users are not impacted, but JSON is stuck. Doesn't matter how much I try, there's going to be a 7-second timeout, and let's see how the UI handles it. Oof, error fetching product review. So you see, this is the kind of things that you might want to just show a big error on the screen and saying, oh, we don't know what happened. You just say, okay, there was an error with that service here, but most of the data are fine. And that was it. If you have more resource, I put the links to an interesting article and blogs that you can find about both service mesh and chaos engineering. I hope you liked it. If you have any question, feel free.
Do you have links to the slides?
Yes, they are on SlideShare. I can post it somewhere. I can send it to Anders or...
Please do.
Yeah, I will. Very good.
Excellent.